Hello everyone. Today I am going to discuss about data sufficiency. How to handle data sufficiency problem in CAT, GRE, GMAT and in IP-MAT exam or other MBA entrance exams. Okay. So first of all we will discuss about the structure of data sufficiency, how question is framed. Each data sufficiency problem, it consists of a question followed by two statements. Look here. Let's say a question is there and two statements are given, S1 and H2. Okay, so how to handle? We have to evaluate each statement. Okay, using this data, first of all, using the data, whatever data is given, we have to decide whether the given data is sufficient to answer the question or not. So following options are given, 5 options, particularly in DS problem 5 options are there, and based on that we have to solve. So particularly the key point is, first of all we will discuss the key point. Okay, what is data sufficiency? Normally in DS what we have to do, now we have to check the uniqueness of the each statement. We have to evaluate each statement, statement 1 and statement 2, and then we have to check the uniqueness. What does it mean? Data sufficiency means unique solution. Unique solution. Unique solution means one solution, straightforward answer. Normally unique solution means we have to think ki either we are looking for a value or by yes or no we can answer. So this is very important. Value, what is this value and what is this yes or no, that I will discuss. When I say unique solution means we are looking for a value. Suppose for example, what is n? What is n? Suppose n, statement number 1, it is given ki n is greater than 10. When I say what is n, here we are looking for a value. How? Now what is n? Here we need to come up with a single value. Here we need to come up with a single value, one value. And when I say n greater than 10, so n become 11, it may be 12, it may be 15, it may be 101, it may be 1000, up to infinity, whatever. Okay, n infinite solutions possible. But here question is find the value. What is n? We need to come up with single value, but here I will get infinite value. So this statement number 1, it is not unique. Okay, more than one values are there. It is not sufficient to answer this question. So statement 1 alone is not sufficient. We have to check for statement 2. Suppose statement 2 is given in this way, ki n is less than 12. So here also lots of values possible. Number of solution is infinity. So this is not possible. This is statement 2 also not unique. So in DS we have to check the unique solution. So we have to think about the value, or we have to think about, or by saying yes or no also we can answer. By saying yes or no means what? Suppose I will say which is x is prime. Suppose statement number 1, it is given x is equal to 2. Is 2 is prime? You said yes. Yes means straightforward answer. One solution. One solution means it is unique. Statement 1 alone is sufficient. Similarly, if I will say x is equal to 4. 4 is prime? No. Straightforward answer. One answer also unique. Here you said no, but this is unique. Unique solution. Unique solution means itself it is sufficient. Statement 2 alone is sufficient. Look, either your answer is yes or no, it does not matter. If you have only one answer, straightforward answer, then that is unique. That statement alone is sufficient. You understood na? So no also equally important. Either you are saying yes or no. If you have only one answer, but if I say, suppose one statement is given in this way, ki x is equal to 2, 4. For 2 you said yes, 2 is prime, but for 4 you said no. Means for some value you said yes, for some value of x you said no. For a single statement you have multiple answers. That is not unique. That statement alone is not sufficient. So in DS what we have to check? Now we have to think either, first of all we have to evaluate both the statement. Then we have to think whether we are looking for a value, or by saying yes or no work is done, means we will get my answer. That we have to think. Clear? yes or no, equally important. If I say no, but if that is one answer, straightforward answer, that is unique. That statement alone is sufficient. But if I said yes, that is also sufficient. So no is equally important. But if I say yes and no, ambiguities are there, complexities are there. So that statement alone is not sufficient. So here we are going to check this uniqueness. Okay. So in DS, data sufficiency, it means unique solution. Unique solution means either my answer is we are looking for a value, or we are saying yes or no. By saying yes or no, my work is done. Okay. So these are two examples. This is for value and that one for by saying yes or no also we can answer. Now how options are framed, that we are going to think. If you want, you can write it down. First, give heading data sufficiency. First key point, data sufficiency means unique solution. Data sufficiency means unique solution. Unique solution means one solution, straightforward answer. If okay, how options are framed in DS? Acha, in DS, data sufficiency, first of all, one question is given. We have to paraphrase this question, simplify the question. Two statements are given. Now we are going to discuss about the option, how options are framed. Two statements are there, statement number 1, statement number 2. First, option number A. Look how options are framed, that is important, you have to remember. Okay, if you solve more question, automatically you can remember all this. Acha, statement 1 alone is sufficient, but statement 2 is not sufficient. This is this is option number A. Statement 1 alone is sufficient to answer the question, but statement 2 is not sufficient. Option B, statement 1 alone is not sufficient, but statement 2 alone is sufficient. Option C, individually both are not sufficient, both are not unique, but together, both the statement together are sufficient, but neither the statement alone is sufficient. Together they are sufficient. So and, okay, if I combine statement 1 and statement 2, then both are sufficient. Okay, if we check whether the combined data, combined information is sufficient to answer the question, then that is possible, that is yes. Clear? So together they are sufficient, that's why here I write and. Option D, each statement alone is sufficient, so here I will write or, so that you can, this is very important, where and is there, or is there. Or means each statement alone is sufficient, but here individually both are not sufficient. Each statement alone, neither the statement alone is sufficient, but together they are sufficient. And the last option, neither the statement alone is sufficient and together also they are not sufficient. And neither the statement alone is sufficient, here more data, more information required, okay, for each statement. Okay, so these are the 5 options we are going to check. Okay, we will solve more questions so that you can understand the thought process, okay, how I will handle. Now if I explain the thought process, okay, so here I will say thought process to handle DS. How to handle DS problem? So first of all, we have to evaluate statement 1 and statement 2 after paraphrasing this original question. Paraphrasing means simplifying the original question. After evaluating S1 and S2, if statement 1 alone is sufficient, you have two choices. Okay, choice number 1, option number 1, here two cases possible. Either it is sufficient, means alone is sufficient, it is unique, statement 1 is unique. If it is unique, then what would be the answer choice? Now here answer is, if statement 1 is correct, if statement 1 is correct, okay, so your answer choice is going to be option A or option D. Understood na? Option A or option D. Here my answer choices are, my answer is either it is A or D. Now who will decide? Now statement 2 will decide my answer. So after that I have to check statement number 2. Now if again for statement 2 you have two choice. If it is sufficient, what happen? Now if it is sufficient, when statement 1 is sufficient, alone is sufficient to answer, and statement 2 also sufficient, so which option is correct? Option D is correct. So here I will get my answer is what? My answer is option D. Clear? Now if statement 2 is insufficient, so my answer is only A. If statement 2 is insufficient, then my answer is A. Clear? Now, if statement 1 is insufficient, here answer is going to be either B or C or E. If statement 1 is insufficient, my answer is either B or C or E. That I have to check. Now who will decide? Statement 2 will decide. Now I have to evaluate statement 2 and there I have to check the uniqueness. So here again two cases possible. If it is sufficient, means statement 1 insufficient, means not unique, but statement 2 is unique. The answer is, here my answer is option B. That is statement 1 is insufficient. Statement 1 alone is insufficient, but statement 2 alone is sufficient. So option B is correct. Now, if it is not sufficient, insufficient, not unique, then answer is either C or E. Here answer is either C or E. Clear? So here what we have to do now, we have to combine statement 1 and statement 2. After combining, again we have to check the uniqueness. If it is sufficient, my answer is C. If it is insufficient, then my answer is E. Flow understood? This flow is very, very important. Once again, these are the options given in DS. First of all, we have to evaluate statement 1. If statement 1 is unique means sufficient, then we have two options. Either option A is correct or option D is correct. Now who will decide? Statement 2 will decide. Statement 2, again you evaluate. Again you have two choices. Either sufficient means statement 2 alone is unique or not unique. If it is unique, statement 1 unique, understood, sufficient, statement 2 also sufficient, then answer is option number D. Now if it is insufficient, answer is only statement 1 alone is sufficient, statement 2 is not sufficient, so answer is option number A. Now if statement 1 is insufficient, here answer is going to be either B or C or E. Who will decide? Statement 2 will decide. Now for statement 2, either it is sufficient or insufficient. If it is sufficient, my answer is option B. If it is insufficient, between C or E, one of them is my answer. So I have to combine both the statement 1 and 2. After combination, you have two choice. Either it is sufficient. If it is sufficient, both the statement S1 and S2 together they are sufficient, but individually neither the statement alone is sufficient. So option C is correct. Now it is insufficient. If after combination it is insufficient, my answer is option E. Okay, together they are not sufficient. Individually not sufficient, together also they are not sufficient. Clear? This is the flow, this is the thought process that we are going to check in each question. After that I am solving the question. Write it down. Okay, we will discuss question number 1. In question number 1, it is given कि if x and y are integer greater than 1, x and y they are integers and it is greater than 1, is xy greater than 100? Is xy greater than 100? Achha, question is xy greater than 100? Here first of all we have to check the unique solution, and when I find the unique solution, first of all I have to think कि whether I require a value, or by saying yes or no I can answer. Here by saying yes or no I can answer, because is xy greater than 100? First of all we evaluate statement 1 and 2, then we will get some values of x and y. Okay, if it is greater than 100, then it will satisfy this solution is unique, that statement is unique. So here when I check the unique solution, by saying yes or no I can answer. Okay, so no need to find the value. Okay, but you can find the value. After finding value it will be easy to say ki is xy greater than 100. Okay, acha, first of all I have to paraphrase, I have to simplify this question. x and y both are integer greater than 1. X and y both are integer means what? Let's say this is the number line 0, 1, 2 up to infinity, and this side this is -1, -2 up to minus infinity. It is greater than 1, and it is greater than 1. So here I can say x comma y, this become 2, 3, 4 up to infinity. So these values are given. Okay. Now statement number 1. In statement 1 it is given x has 7 unique factors. Acha, first of all find this x. X has 7 unique factor means if I write any prime number to the power 6, can I write x is equal to this? Any prime number to the power 6. You know how to find number of factor? Now power plus 1, 6 plus 1, 7. So 7 factors, x has 7 factor. Acha, what is the minimum value of x here? Minimum value is, if I say 2 to the power 6, this is the minimum one. If I will consider 3, 5, 3 to the power 6, 5 to the power 6, 7 to the power 6, it will give me the answer, but I want the minimum value. Here minimum value is 2 to the power 6, that is equal to how much? 64. Now I have to check, is xy greater than 100? Acha, what is x into y here? X is equal to 64. And here y minimum is what? Y 2, 3, 4. So if I put y equal to 2, this is equal to how much? 128. This is greater than what? This is greater than 100. And here is xy greater than 100. Yes. Similarly, if I put x is equal to 64 and another value of y, when 64 into 3, that is also greater than 100. And yes or no? You said yes. Here you said yes. Here also you said yes. Similarly, if I put y equal to 4, y equal to 5, it will satisfy. So here for every value of, or for all the values, okay, of x and y, you said yes. One answer. Yes, straightforward answer. So statement 1 alone is sufficient. So this is unique. Statement 1 alone is sufficient. Done. Now I am going to check for statement number 2. So for statement 2, here it is given y has exactly 9 unique factors. Achha, 9 factor means you have two choices. Okay. You can write case number 1. You can write y, this is equal to any prime number to the power 8, one case. Another case is, you can write y that is equal to any prime number 1 to the power 2 into prime number 2 to the power 2. Because how to find number of factors? Now power plus 1, 2 plus 1, 3. Here 2 plus 1, 3, 3 into 3, 9. So here you have two cases. Now I will check y minimum. Can I find y minimum? Just like the previous. Y minimum 2 to the power 8, that is equal to 256. Now if I am going to find x into y minimum. Minimum value of x is what? 2. So 2 into 256, it is greater than 100. And here 2 into 256, it is greater than 100. Okay, that is equal to 512. 512 greater than 100. Similarly, if I put 3 into 256, that is also greater than 100. So for all values of x, it is satisfied. You said only single answer. So this is yes. The answer is yes. Is xy greater than 100? For case 1, you said yes. Straightforward answer. Now I am going to check for case number 2. So here prime number square. Prime number square means if I write there 2 square. If I write here 2 square. 2 square, this is 4. And here it is 3 square. Okay. So 2 square, this is the minimum value. Here first of all I am going to find the minimum value. 2 square into 3 square. This is 4. 4 into 9, 36. So y minimum 36. Now if I consider x is equal to 2. When I consider x equal to 2, 2 into 36, it is 72, which is less than 100. So here 2 into 56, means x into y, this is equal to 2 into 36, that is 72. For 72 you said no. Is xy greater than 100? No. Now if I say 3, acha 3 into 36, yes, it is possible. Okay, 3 into 36, it is greater. Okay, that means for one value, for 2 you said no, and for 2 you said no, but for 3 you said yes. For 4 also you said yes, because 4 into 36. Again it is greater. Okay, 144. 144 is greater than 100. So after 2, for 3, 4, 5 up to infinity, this is satisfied. Xy greater than 100. But for 2 you said no. And for some value you said yes. And for 2 you said no. And for single statement you have multiple answer. Multiple answer means this is not unique. This statement is not unique. Not unique. Statement number 2 is not unique. Statement number 2 is not unique. 1 is unique. Okay, so here answer is what? Answer is statement 1 alone is sufficient to answer, but statement 2 is not sufficient. So which option is correct? If you observe, option A is correct. Option A, because in DS, first option A is what? Statement 1 alone is sufficient, but statement 2 is not sufficient. So this one is satisfied. Answer for this question is option A. Write it down, then we will discuss question number 2. Look here, the thought process, how I handle this question. This is important. Okay, look at question number 2. If x and y are positive integers, question is x is a factor of y? Okay, so here by saying yes and no, I can answer this question. Achha, first of all, is x, y are positive integer? Here it is given both x and y, these are positive integers. So this is 1, 2, 3 up to infinity. These are the values of x and y. Achha, first of all, in DS, options are what? 2 statements are given. In short, here I will write so that you can try this question first. Statement 1 alone is sufficient, but statement 2 is not sufficient. Option B, statement 1 alone is not sufficient, but statement 2 is sufficient. Option C, both the statement together are sufficient. Option D, individually each statement alone is sufficient, so or. And the last option is both the statements together are not sufficient. So 5 options. First you try, options are given. Okay, so first I will discuss, I will evaluate statement 1. Statement 1, what it is given? Now here x is equal to y square, and x and y values are also given. Okay, so here if I put y is equal to 1, so x is equal to how much? X is equal to 1 square, this is 1. Here question is x is factor of y? You said yes. Is x factor of y? You said yes. Now if I will check y is equal to 2, for 2 I am going to check. So here x is equal to how much? 2 the square, this is 4. Is 4 is a factor of 2? You said no. For single statement, one case, for one value of y, you said yes. For one value of y here, another value, for another value you said no. And for single statement you have multiple answer, so ambiguities are there. Ambiguity means complexities are there. Complexity means this is not unique. Statement 1 is not unique. Statement 1 is not unique means what? Now statement 1 alone is not sufficient. Okay, now I am going to check for statement number 2. So in statement 2, here y is greater than 1. So y values are 2, 3, 4, lots of value, infinite value possible. But no relation is given between x and y. In statement 2, I don't know what is x. Okay, no relation is established. So this is not sufficient, not unique. So statement 2 here alone is not sufficient. So when statement 1 alone is not sufficient, so you can eliminate option A and option D. If statement 1 alone is not sufficient, just elimination method, okay? And here after evaluating statement number 2, statement 2 also alone is not sufficient. Statement 2 alone is not sufficient means option B is also not correct. You can eliminate. Now between C and E I have to choose. Achha, C and E. Concept is what? Now we have to combine both the statement 1 and 2. If I will combine both the statement, what is the common element? So here x this is equal to y square, and here y value it is greater than 1. I mean here y values are what? Y values are 2, 3, 4 like this. And for each y value, if I am going to find the x, this is x is equal to 2 raised to square 4, this is 9, 16 like this. Here, can 4 is factor of 2? You said no. Can 9 is factor of 3? No. For 16 is factor of 4? No. I mean a straightforward answer. For each statement you have a straightforward answer. You said no. So this is unique. This is unique. Unique means combine. If I combine 1 and 2, both the statement, it is unique. Unique means it is sufficient to answer. That means which option is correct? Option C is correct, because option C is statement 1 and statement 2. Both the statement together are sufficient, but neither the statement alone is sufficient. Both are insufficient, not unique. But if I combine, you have a single answer, straightforward answer, no. Understood now? So this is the way you have to handle this. Easy. When question is very easy, there is a trap. You should be careful. Okay. So this is the thought process to handle what? DS. Question number 3 we will discuss. First of all, you take this screenshot or write it down. Okay. Question number 3. In question number 3, it is given x is an integer. Is 3 to the power x less than 500? First of all, I have to simplify this. 3 to the power x less than 500. 3 to the power x less than 500 means what? You know, 3 square, 9 cube, 27, 3 to the power 4, 81, 3 to the power 5, 243. Here, if I simplify this one, you can say x is what? Less than 6. That means question is x is less than 6. That I am going to check. Okay. So individually I will evaluate statement 1 and 2 and then I will check is x less than 6 or not. Now statement number 1. If I will evaluate, find the value of x here. 4 to the power x minus 1, it is less than 4 to the power x minus 120. So here this can be written as 4 to the power x into 4 to the power minus 1. If I take 4 to the power x to left hand side, this is minus 4 to the power x less than minus 120. So here if I will take 4 to the power x common, this is 1 by 4 minus 1, it is less than minus 120. So here 4 to the power x, LCM here is 4 and this is 1 minus 4, this is minus 3. This is less than minus 120. Now if I multiply negative sign both sides, the inequality sign will change. So this can be written as, here I will write, now multiply, so minus minus get cancelled, so this become greater than, and if I do cross multiplication, 4 to the power x, it is greater than 120 into 4 by 3. So 3 into 4, 12, so 40, 40 into 4, 160. So here 4 to the power x, it is greater than 160. Achha, if 4 to the power x is greater than 160, so what are the values of x here? So here x is what? 4 to the power 3, that is 64. 4 to the power 4. Okay, here x is what? Greater than 4. Here x is greater than 4. X is greater than 4 means, so these are the values. For 4 it is satisfied, or you can say x is greater than 3. X is greater than 3 because 4 to the power 3. Okay, this is equal to how much? 64. So this is 4. So x is greater than equal to 4. So this is 4, 5, 6, 7 up to infinity. Infinite values possible. Clear? 4 to the power x greater than 160. 4 cube is 64. 4 to the power 4 is 256. So 256 greater than 160. So x greater than equal to 4. Equal to symbol. Greater than equal to. Done. Now here is x greater than 6? Is x less than 6? Yes. Is x less than 6? 5 is less than 6? Yes. Is x less than 6? No. Is x less than 6? No. For few value of x you said yes, and for rest of the value you said no. So this is not unique. Statement 1 is not unique. Statement 1 alone is not sufficient. Not sufficient means you can eliminate. If I will frame the options again, statement 1 and for statement 2 I am going to write the option Option A, statement 1 alone is sufficient, statement 2 is not sufficient. Option B, statement 1 alone is not sufficient, statement 2 is sufficient. Option C, both the statement together are sufficient. Option D, both the statement alone is sufficient. And option E, together they are not sufficient. Individually they are not sufficient, together also they are not sufficient. Acha, here conclusion is what? Statement 1 alone is not sufficient. Statement 1 alone is not sufficient means you can eliminate 1 and you can eliminate option D. When option A and D you can eliminate. Done. Now I am going to check for statement number 2. Here statement 2 is what? X square is equal to 36. So here x is equal to plus 6 means plus or minus 6. Plus 6 minus 6. For plus 6, and here x has two value. Plus 6 minus 6. For plus 6, is x less than 6? You said no. For minus 6, you said yes. Is x less than 6? You said yes. Again ambiguity. Multiple answer. Multiple answer means not unique. Statement 2 also not unique. Statement 2 not unique means option B you can eliminate. Done. Now we have to combine both the statement. Statement 1 and statement 2. If I combine, what I will get? The common element. Here x is what? These are the value. And for x here plus 6 minus 6. So the common value is what? X is equal to 6. If I combine, I will get x is equal to 6. Is x less than 6? Is x less than 6? You said no. Straightforward answer, you said no. And is x less than 6? You said no. No means single answer. So it is unique. It is unique. It is unique. Unique solution. And unique solution means individually they are not sufficient, but together they are sufficient. So which option is correct? Option C is correct. So answer for this question is option C. Answer for this question is option C. Understood na? The flow. It is important. First of all, you evaluate statement 1, statement 2, check whether these data are sufficient or not. If they are not sufficient, you combine both the statement. If I combine both the statement, I will get x is equal to 6. Then question is x less than 6? You said no. One answer. Straightforward answer. So it is unique. So which option is correct? Option C is correct. Okay, question number 4. In question number 4, it is given, is x greater than 10 to the power 10? And here power is 10. Okay. So whenever power is a bigger value, we take logarithm. Okay, log. So first of all, I will paraphrase this one. I will simplify this one. X greater than 10 to the power 10. If I take log both sides, then log base 10, log x to the base 10, it is greater than log 10 to the power 10 to the base 10. Okay. So here if I simplify, 10 will come to this position. Log m to the power n to the base a. This can be written as n into log m to the base a. Log m to the base a. I will apply this one. So here log x to the base 10, it is greater than what? 10. Because second, this is first rule. Second rule, log a to the base a, this is 1. When these two values are same, answer is 1. So log 10 to the base 10 is 1. So here log x is greater than 10. Okay, that I am going to check. So individually, first of all, I will evaluate statement 1. So here x is greater than 2 to the power 34. If I take log both sides, okay, so here log x to the base 10, it is greater than log 2 to the power 34 to the base 10. 34 come to this side. So log x to the base 10, it is greater than 34 into log 2. What is log 2? The value. It's an irrational number. But if after decimal, if I will consider 2 digit, so its approx value is 0.30. Done. So if I multiply, how much I will get? Now here log x to the base 10, this is greater than what? 12 to carry 1, 9, 1, 10. So 10.2. So is log x Greater than 10, you said yes, because here I will get 10.2. So here answer is yes. Yes. Yes means statement 1 alone is sufficient. Statement 1 alone is sufficient. Okay. Statement 1 alone is sufficient means either my answer is option A or option D. Between these two I have to choose. Either answer is option A or D. Between A or D I will choose my answer. D also. Okay. Between A or D I have to choose. I can eliminate B, C and E. Now I have to check statement number 2. Here I will check statement 2. In statement 2 it is given x is equal to how much? 2 to the power 35. So if I take log both side, so this is log 2 to the power 35 to the base 10. So here 35 into 0.30. So this is 15, 5 carry 1, 9, 1, 10, 10.5. Here I will get log x base 10, it is 10.5. Is log x to the base 10 greater than 10? You said yes, because here I will get 10.5. Here also yes. Yes means unique. Unique means statement 2 alone is sufficient. So which option is correct? Option D is correct. Option A is wrong. When both the statement alone is sufficient. Both the statement alone is sufficient. Statement 1 is unique as well as statement 2 also unique. Both are unique. One is single answer. Here log x to the base 10 greater than 10. So here I will get in statement 1 I will get log x to the base 10, it is greater than 10.2. Is log x to the base 10 greater than 10? Yes. In statement 2 I will get log x to the base 10 is 10.5. Is log x to the base 10 is greater than 10? Yes. So both are unique statement. So for unique statement option D is correct. Okay, write it down. Question number 5. In question number 5, is x greater than 0? Means is x positive? This is the question mark. Now we are going to evaluate statement number 1. In statement 1 it is given x cube is less than x. X cube is less than x means we will check. Acha, for here for integer you can put x is equal to plus or minus 1 plus or minus 2 like this, and for fraction for if you want to check the values you can check for plus or minus 1 by 2 plus or minus 1 by 3 and so on. So here I will check if I will put, because here it is given x is what? X is an integer, it is greater than 0. If it is greater than 0, this one I am going to check is x greater than 0, and it is not given key either x is integer or fraction, so we will check for both. So for integer if I will take 1, x is equal to 1 cube less than 1, not satisfied, condition not satisfied. Similarly if I will take negative value, if I will consider minus 1 cube less than 1, minus 1 cube, this is equal to what? Now minus 1 less than 1, yes. Minus 2 cube less than 1, yes. Clear? Similarly minus 3 cube less than 1, yes. All are negative values, it is less than 1. So here you said yes when x is equal to minus 1, minus 2, minus 3 up to minus infinity. For these values you said yes, and this condition satisfied. The condition satisfied. Now is x is positive here? Is x is positive? You said no, x is not positive. Similarly if I am going to check for fraction, if I will put 1 by 2, 1 by 2 cube, it is less than 1 by 2, yes, because this is 1 by 8 is less than 1 by 2. Similarly 1 by 3 cube, it is also less than 1 by 3, clear? Because this is 1 by 27, this is 1 by 4 cube, it is less than 1 by 4, yes. I mean here x, possible values of x are what? Now this is 1 by 2, 1 by 3, 1 by 4 and so on. Is x is positive here? Yes. And is x is positive? You said yes. For few value of x, you said no, and for few value of x you said yes. So statement 1 alone is not sufficient. So this is not unique. This one is not unique. Statement 1 alone is not sufficient. Not unique means you can eliminate option A and option D. Now between B, C and E, I am going, this is my possible answers, okay? B, C, E. Who will decide? Statement 2 will decide. As a statement 2 is x is even. Statement number 2, x is even. X is even means x can be plus or minus 2, plus or minus 4, plus or minus 6 and so on. So if I say plus 2, plus 4, plus 6, it is even. If I say minus 2, minus 4, minus 6, these are what negative value. X is there even, but here two possibilities. X is equal to 2, 4, 6 and infinity even, or minus 2, minus 4, minus 6 up to minus infinity. Acha, here is x is positive? Yes. For this you said yes. And for this one, is x is positive? You said no. It is single statement but multiple answer. So statement 2 alone is not sufficient. Statement 2 alone is not sufficient. Not sufficient means not unique. Okay? It is not unique. Not unique. Not unique. Clear? If it is not unique, the option B you can eliminate. Now I have to combine these two statements. If I combine these two statements, here x is equal to this and these are the fraction value, and there x is equal to what? 2, 4, 6 up to infinity and minus 2, minus 4 up to minus infinity. Achha, if I combine, I can write x is equal to statement 1 and statement 2. If I combine, so here x is equal to what? Minus 2, minus 4, minus 6 up to minus infinity. Here is x is positive? You said no. Here is x is positive? You said no. Straightforward answer. Unique answer. Unique answer means which option is correct? Option C is correct. Here is x is positive? Minus 2, minus 4, minus 6. You said no. No means single answer. Single answer means if I combinely together both the statements are sufficient, but individually they are not sufficient. Okay, so solve this. These are good questions. Okay, statement 1 it is not unique, statement 2 also individually not unique, but together they are sufficient. Clear? So this is the way we have to handle what? DS questions, data sufficiency questions. Thank you.